Hello, I'm Dr. Miller, math magician. I'm here to talk to you about negative numbers today, and hopefully I will confuse you about math. But in terms of that confusing process, you will understand math and negative numbers better. So let's begin our presentation. How would you go about to discover zero and negative numbers? Let us take a look at the number line. 1, 2, 3, 4, 5. An arbitrary set of names and an arbitrary set of symbols, but we've learned to memorize those. And so we would know that the next number is 6. But what is the number before 1? Oh, I'm a kindergarten student. Nobody ever told me. I don't know. What is 5 minus 3? Well, that's minus 2. Well, I know that because 2 plus 3 is equal to 5. But what's 3 minus 5? I don't know that either. Asking questions is how we learn. We need to build upon what we know. We create our numbers by adding 1 to the previous number. Oh, one more. Subtraction is inverse addition. Let's make some numbers. We begin by adding 1 to the previous number. So 3 is equal to 2 plus 1, because 2 is the number before 3. Well, then 1 would be equal to z plus 1, because z is the number before 1. Well, we notice that 1 is on both sides of the equation. So if 3 is equal to 2 plus 1, then we could substitute for 1, z plus 1, and we get that's equal to 2 plus 1 plus z, but 2 plus 1 is 3. So we get 3 is equal to 3 plus c. When we add 3 to z, we get 3. In order to illustrate this, we had to assume with addition that numbers had the commutative property, 2 plus 3 is the same as 3 plus 2, and the associative property, 5 plus 6 plus 3 is the same as 3 plus 5 plus 6. We make rules, commutative and associative, based upon observation. Our conclusion is when we add z to a number, we get the number as the answer. Looking at 0 in different environments, we could rename z equal to 0, but on a clock, we could rename it z is equal to 12, because 12 is the number before 1. So on a clock, or a number circle, 12 has the same additive property as 0 on the number line. In both cases, they are number before 1. What were you told about 0? Did you challenge what you were told? Here I am explaining my reasoning. We know that now that a plus 0 is equal to a. Well, then if we subtract a, reverse addition, we get that a minus a is 0. So when we subtract a number from itself, we get 0. We note that 2 is equal to 1 plus 1. Well, 1 can be replaced by 1 plus 0, and we find that we now get 1 plus 1 plus 0 plus 0. Well, 1 plus 1 is 2. Well, we know that 2 is also equal to 2 plus 0. So we might conclude that adding 0 to itself gives us 0. Well, multiplying number times 0 is adding the number to itself that many times, and we keep adding them in pairs, and we finally get 0. Why is 0 times 5 0 then? Well, it turns out we believe in the commutative and associative properties. So we just take the commutative property, and we know that 0 times 5 is equal to 0 because 5 times 0 is equal to 0. Enough about 0. Let us continue our backward search. A plus 1 is equal to 0 because a is the number before 0. Well, if we use inverse addition, we find that a is equal to 0 minus 1. Well, let's call that negative 1. Then negative 1 plus 1 must be equal to 0 if we substitute in for a. And this becomes our definition of a negative number. If we continue, b plus 1 is equal to a. But if we add 1 to both sides, we get b plus 2 is equal to a plus 1. But we know a plus 1 is 0, so b plus 2 is 0. Subtracting or doing reverse addition, we find that b is equal to 0 minus 2. Oh, we could call that negative 2, just as we did with negative 1. So now we see that we get some consistency. Well, let's say a little bit more about 0. 0 plus 0 is equal to 0. Therefore, 0 is equal to 0 minus 0, reverse addition. Well, that's the way we define our negative numbers. Minus 0 occupies the same place on the number line as 0. That is why it does not get its own place. Let's look at the clock. As we mentioned, 12 is the number before 1. 11 is the number before 12, and 10 is two numbers before 12. So a plus 1 should be equal to 12, and b plus 2 should be equal to 12. Well, a is equal to 12 minus 1, and b is equal to 12 minus 2. Using our definition of the number before 1, and we would define that as -1 and -2. Well, 11 occupies the same place as -1, and 10 occupies the same place as -2. Well, let's see what happens when we add 10 to 4. We get 14, and we subtract 12 and discover that's 2. But we could also put in -2 for 10, and 4 take away 2 is 2. It's easier to subtract 2 than add 10 and subtract 12. So what are the rules now that we know what negative numbers are? Well, the first one is the definition. When we add a negative number to itself, we get a positive, we get 0. And therefore, if we use reverse addition, we would also find that 1 is equal to 0 minus -1. So when we subtract a negative number, we get a positive number. So subtracting a negative number is the same as adding a positive number. Let's take another example. 5 plus -2 is equal to 5 plus 0 minus 2, because that's what -2 is equal to. And 5 plus 0 is 5, and 5 minus 2 is 3. So adding a negative number is the same as subtracting a positive number. Now, there's two more rules we'd like to learn. If we take our definition and we see that -2 plus 2 is 0, -3 plus 3 is 0, rearrange our numbers. So we have the negative numbers together and the positive numbers. You see that 2 plus 3 is 5. And we know that if we add -5 to 5, we will get 0. So therefore, we conclude that -2 plus -3 is -5. So when adding negative numbers, we add them as positive numbers and put a minus sign in front of the answer. Well, we could rearrange them in another way. 5 plus -3 and 3 plus -5. But we know when we add a negative number, in rule 2, that's the same as subtracting a positive number. Okay, and now we take the 5 minus 3 over to the other side, reverse addition, and we get that 3 minus 5 is equal to 0, minus 5 minus 3. Well, 5 minus 3 is 2, and -0 minus 2 is -2. So we see that when subtracting larger numbers from smaller numbers, subtract the smaller number from the larger and make the answer negative. We could do this with manipulatives. I'm not particularly happy about manipulatives. They're merely an application, but sometimes for some people it makes it easier to understand things. So a brown penny plus a blue penny, our rule is that makes 0. Okay, and now we try to subtract a negative number from a positive number, as we're doing here. What we find is, in order to get that negative number, we had to add in 2 zeros. So now we have a negative number to subtract. When we take these out, we're left with these 2 brown pennies. So a negative number subtracted from a positive number is the same as adding that positive number. If we add a negative number, that cancels out 2 of our pennies, and we're left with 2 pennies. So adding a negative number is the same as subtracting a positive number. And if we add 1 blue penny to 3 blue pennies, we get 4 blue pennies. Well, adding negative numbers, we add them as positive numbers and make the result negative. And the last one is we'd like to take 3 pennies away from 2 pennies. But we don't have 3 pennies to take away. So what we do is we add in 0. Shouldn't change things any. We have that extra brown penny we need. When we take it away, we're left with 1 blue penny. So this is verifying our rules using an application. Now, we talk about negative numbers with respect to addition, but what happens if we multiply negative numbers? Well, 5 times -1 would be 5 minus 1. So we know we add negative numbers as positive numbers, make the result negative. So that would be -5. What's -5 times 5? I don't know how to multiply negative numbers. But I do know the commutative rule. So if 5 times -1 is Negative 5 minus 1 times 5 is negative 5. Now let's take another look at things, and we find that 10 is equal to 2 times 5, 5 is equal to 1 times 5, and 0 is equal to 0 times 5. And what we're doing is subtracting 5 each time. Well, 0 take away 5 is minus 5 take away 5 is minus 10. So if we take the pattern 2, 1, 0, next would be minus 1, minus 2. And so we would draw the conclusion that a negative number times a positive number is a negative number. Sort of verifies our commutative property there. Now, if we did another operation, 2 times minus 3 is minus 6, 1 times minus 3 is minus 3, and 0 times minus 3 is 0. So in this case, we see we're adding 3. 3 plus 0 is 3, and 3 plus 3 is 6. So continue our 2, 0, minus 1, minus 2, we get a negative number times a negative number is a positive. Okay, now, again, examples or applications, not as much meaning as when we do them by proofs. So here we have minus 3 times 5 plus minus 5. 5 plus minus 5 is 0. And minus 3 times 0 is 0. So minus 3 times 5 plus minus 3 times minus 5 we get as a result of the distributive property. And then we take and subtract the minus 3 times 5 from 0, and we're subtracting a negative number, which is the same as adding a positive number. So negative 3 times negative 5 is equal to positive 3 times positive 5. Well, we could continue. Look at this. A negative number times a negative number is a positive number. So when we multiply like numbers, we always get a positive number. When we multiply numbers of opposite signs, we get a negative number. So we ask the question, what number multiplied by itself will give a negative number? Well, it can't be 1 times 1, because that's plus, and minus 1 times minus 1 is plus. What are we going to do? Well, mathematicians just make things up. So we define something called I squared, which is I times I is equal to minus 1. Well, if we sort of take the square root, we get I is equal to the square root of minus 1, or minus 1 to the 1/2. But is that really the case? If we take the square root of minus 1 times the square root of minus 1 and bring them inside the radical, since that's what we do when we take the roots of something, minus 1 times minus 1 is plus 1. Well, the square root of 1 is 1. It's not minus 1. We also discovered it could be minus 1 too. So you have to be a little bit careful of thinking of I as the square root of minus 1. More confusion. Okay, what's 2 plus 2? Well, we know it's 4. Could it be 0 minus 4? Well, if we represent 2 by the square root of 4, then the square root of 4 plus the square root of 4 is 2 plus 2. But both of those square root of 4s could be minus 2, because we know minus 2 times minus 2 is 4. So that gives us minus 4 as the answer. And if we take one of the square root of 4s as negative and the other is positive, we get 0. So we have to be very careful when we're studying things in order to try to bring things into consistency in our own minds. Now, in order to remember what we've learned, we have to summarize it. There's about 13 pages or so of dialogue that we went through. Here's just one page. Definition of negative number. When we add a negative number to its inverse, we get the identity element for addition. Subtracting a negative number is the same as adding a positive number. Adding a negative number is the same as subtracting a positive number. So we're reversing those two. When adding negative numbers, add them as positive numbers and put a minus sign in front of the answer. It's pretty easy to remember. And when subtracting larger numbers from smaller numbers, subtract the smaller from the larger and make the answer negative. And by practicing these, it makes it easy for us to remember the rules. And our fifth rule is the product of numbers of like sign is positive, which leads us to draw the conclusion that I squared is equal to minus 1. Thank you very much for listening to the presentation.